For the calculation section, I've given you a frequency distribution that has a frequencies have already been calculated for vertical jump height intervals of 2 inches from 12 to 34. So all of these frequencies are inclusive of the lower bound and exclusive of the upper bound, since all of these upper bounds have been repeated, except for the final group, which is inclusive of 34. So the first question we're asking here is, what type of distribution is shown? If you said grouped frequency distribution, you would be correct. Okay, and I spelled that wrong. If we had a distribution where we just had 12, 13, 14, 15, 16, all the way through 34, without any intervals greater than a unit of 1, then we would have a simple frequency distribution. Now, that's not to say that we could also have intervals less than 1, but when you just put whole numbers in a distribution and you're looking at the frequency of that whole number from a set of data, that would be a simple frequency distribution. The question we have attached to this frequency distribution is, what is the exact percentile for a jump height of 27.2 inches? So in order to find this, the easiest way we can make this calculation is to copy our table, and then we can paste our data into our Excel spreadsheet. This is just the other calculations tab that I have for any miscellaneous calculations you'll be doing for the review. What I'm going to do is actually add a column. So for this, we'll have a lower bound, an upper bound, and a frequency, just so we can separate out our values for our calculations. Oops. Hey. There we go. I don't know why that was being so weird. Okay. All right, so now I've basically just relisted my upper and lower bound values, and then this is my frequency column. I need a cumulative frequency column in order to calculate my percentile, and let's write this over here. I have an X value of 27.2. I'm interested in figuring out the percentile using our group frequency formula. So the first thing we need to do is calculate our cumulative frequencies by starting at the worst end of our distribution. So the lower the jump height, the worse the score. Our cumulative frequency in our first group is the frequency of that group, and then the cumulative frequency of each subsequent group just adds the frequency of that group. We drag that down, and we can see that we have a total sample size of 100. So for our percentile, we do equals 4 parentheses, our raw score minus the lower bound of the interval it belongs in, so at 27.2 would go between 26 and 28, so 26 is the lower bound value. That difference is divided by the interval size, which we can find by taking the difference between two adjacent lower bounds or two adjacent upper bounds. We can see that's 2 inches. We then multiply by the frequency of the group that 27.2 is in, add the cumulative frequency of the group that's worse than that's the group that 27.2 is in. We divide that numerator by the sample size, which is 100. And then we multiply that entire result by 100 to get a percentage. Now, increase our decimal places, and we actually have a perfect 77% or 77th percentile for a person who jumps exactly 27.2 inches.